Hello everyone. In this video we will see three important questions on the combination of vector and permutation and combination, that is the positive integral solution of the given equation or non-negative integral solution of the given equation. So let's see the first question. The position of a point P is given by this vector R is xi plus yj plus zk, where x, y, z belongs to the natural numbers. So x, y, z belongs to the natural number. So the value of x, y and z are positive integers. Positive integers. And u is I plus j plus k. If r dot u equal to 10, then the possible position of p are. So let's solve it. So this is r dot u, that is equal to 10. Okay. So this gives xi plus yj plus zk. U is, what is that? I plus j plus k, and that is equal to 10. So we are having the equation now. X plus y plus z, that is equal to 10. So this is your equation, and you have to find out the positive integral solution. Positive integral solution. So the positive integral solution. Now look at the formula. See, this is the equation x1 plus x2 plus up to the xr, that is equal to n. So if xi is greater than equal to 0 or xi is greater than equal to 1. So there are the two varieties of questions we can find out the solution of this equation. Xi is greater than equal to 0 means non-negative integral solutions. Integral solution. And x is greater than equal to 1 means positive integral solutions. Positive integral solution. So this solution is given by n plus r minus 1 c r minus 1. This is the formula. And this is given by n minus 1 c r minus 1. So here positive integral solution, therefore we have to use this formula, correct? So therefore here n is 10, n minus 1 c r minus 1, that is 10 minus 1 c r means these 3 minus 1, that is 9c2 is your answer. 9c2 means 9 into 8 by 2, 36. 36 is your answer. So the only thing is that you have to understand these two formulas. This is the formula to find out the non-negative integral solution and this is the formula to find out the positive integral solution of this equation, correct? Okay, let's do the second question. Now this question is involving the inequality. There we are having the equality. What the question says that if A equal to this vector I plus j plus k. Now in both the question you are observing that this I and j and k are having the scalar component 1 only, correct? And R be a variable vector such that the r dot I, r dot j and r dot k are positive integers. So we have to find out the positive integral solution of that equation. That is, we have to use this formula n minus 1 cr minus 1 for x1 plus x2 plus up to the xr, that is equal to n. For this equation, we have to use this formula to find out its positive integral solution. If r dot a is less than equal to 12, so देखो r dot a less than equal to 12. Okay, so let r is a variable vector means I can put r as xi plus yj plus zk dot a vector is I plus j plus k less than equal to 12. So we are having x plus y plus z is less than equal to 12. So it is less than equal to 12. So therefore cases we will have. Case 1, x plus y plus z equal to 1. Correct? Correct? But every x, y and z has to be greater than equal to 1. X has to be greater than equal to 1, y has to be greater than equal to 1, z greater than equal to 1. So therefore this case is not possible. Similarly, when x plus y plus z equal to 2, this case is also not possible. From here we can think about x plus y plus z equal to 3. Therefore, we are having one solution. How we can find out? By using the formula. 3 means 3 minus 1 c. Okay. Then again 3 minus 1, that is 2c2. 2c2 is coming to be 1. Na? Correct? 2c2. Correct. Okay. So now coming to the case number 4. Case number 4 is, case number 4, here I am writing. Case 4, x plus y plus z equal to 3 के बाद 4. So this equation is given by 4 minus 1c, 3 minus 1. So 3 minus 1 is always there in the suffix, that is 3c2. Correct? This is 2c2, this is 3c2. So finally you can have the last case. Correct? When x plus y plus z equal to 12. So that will be definitely 12 minus 1, c3 minus 1, that is 11c2. Correct? 11c2. Got it? Now you can identify, or you can sum all the solutions. So this solution is 2c2 plus 3c2 plus 4c2. Like that we are going up to the 11c2. This is your answer. You have to now simplify. 2c2 can be written as 3c2 plus, 3c3. Okay. 3c2 plus 4c2 plus up to the 11c2. 2c2 means we are writing NCR equal to NC n minus R. No. This is NCL. NCL. We are using this formula. NCL equal to 1. So it is 2c2 or 3c3 or 4c3, that is same. Now I am using next formula, that is NCR plus NCR minus 1. This is equal to N plus 1 CR, means 1 at, and that bigger R minus 1 and R, bigger is R is there. So now I can apply that formula. Can we apply? Yeah, easily we can apply. This will convert it into the 4c3. Then 4c3 plus 4c2. Again it will convert it into the 5c3. So 3 is always there in the suffix. Finally 1 is added. So this is equal to 11 plus 1 means 12c3. 12c3 will be your answer. 12c3. You can also have, it is equal to the 12c9 by NCR equal to NC n minus R. So this option is also correct. 12c3 and 12c9. Last question we will see. Now this is the bigger question. Okay. How it is? If the vector A equal to I plus j plus 4k. See, this 4k, due to this 4, this question is different from the previous one. Correct? In the previous one, the A vector is always given as a I plus j plus k. So that x, y, z greater than equal to 1 conditions. Okay, that we applied the n minus 1 cr minus 1, which is representing the positive integral solution of the equation x1 plus x2 up to the xr, that is equal to n easily. But here A vector equal to I plus j plus 4k, and R be a variable vector such that r dot I, r dot j, r dot k are positive integers. So that shows that the we have to find out the positive integral solution of equation which we will get from over here. Correct? So therefore we have to apply that formula, n minus 1 c r minus 1. One more formula is there, n plus r minus 1 c r minus 1. This we will apply when they will ask about the non-negative integral solutions, non-negative integral solution, but they are asking about the positive integral solution. Therefore we will use this n minus 1c r minus 1 ka formula. Okay, fine. Now here we are giving r dot a is less than equal to 14, correct? See, r dot a is less than equal to 14. r को मैंने ले लिया xi plus yj plus का z k, and a is here I plus j plus 4k, so less than equal to 14. So therefore we are having x plus y plus now 4z less than equal to 14. Now the question is how to do this, how to solve this, how to find out the positive integral solution. Correct? Because this formula n minus 1c r minus 1 formula is valid when the coefficient of x1, x2, x3 up to the xr is always 1. But here the coefficient of x is 1, okay, y is 1, but z is not 1. So what we will do? We will give values to the z first. So case 1 I am doing, case 1 here. Case 1, if z equal to 1. So z equal to 1 means we are having only x plus y is equal to 14 minus 4, that is 10. So less than equal to 10. Now this equation we have to find out the positive integral solution. So less than equal to 10 means x plus y equal to 1. X plus y equal to 1, not possible because x has to be 1, r greater than 1, y has to be 1, r greater than 1. So therefore this case not possible. But yeah, x plus y is equal to 2 possible, correct? So I can write down one solution only. Directly you can use the formula 2 minus 1c, 2 minus 1. That is 1c1. And then x plus y is equal to 3. So therefore 3 minus 1c, 2 minus 1. That is 2c1. 1 is there always. So therefore for, and 3 is there, then 2. X plus y is equal to 4. Directly I can write 4 is there means 3, 3c1. Finally we are having up to the x plus y equal to 10. 10 means you have to 9c1. So we are having how much solution? 1c1 is 1, 2c1 is 2, 3c1 is 3, up to the 9c1 is 9. So adding these 1 plus 2 plus 3 up to the 9 is very simple. 9 into 10 divided by 5, that is equal to 45. So the first case gives the 45 solutions. Case 1 gives when z equal to 1 gives the 45 solution. Correct? So if z is equal to 1, then we are having 45 solution. Now case 2. Case 2, z equal to 2. When z equal to 2, it becomes 8. 8 means 6. So therefore x plus y is less than equal to 6. Correct? So when I will take x plus y is equal to 1, 2, 3, 4, 5 and 6. This is not possible. This will give one solution, that is given by 1c1. This will given by 2c1, 3c1, 4c1, 5c1 directly. So that is 1 plus 2 plus 3 plus 4 plus 5. But that's it. Correct? 5 into 6 by 3 by 2, that is equal to 15. So 45 case 1 solution gives, and case 2 when z equal to 2 we are having 15 solutions. Up to this we are having 60 solution. Now coming to the last case, case 3. Why I am saying it is a last case? Because z equal to 3, when z equal to 3 we are having x plus y is less than equal to, this is 14, 12 minus from 14, that is 2. So less than equal to 2. So this gives x plus y is equal to 1. No solution because x and y both has to be greater than or equal to 1. So we are only having with this one, that is x equal to 1 and y is equal to 1. That is only one solution. This gives only one solution. Finally we are having 61 solution for this equation. That is we are having 61 different position vector r such that this satisfied this r dot a less than equal to 14. So this question is very good. All those questions we have discussed in this video is actually your for your JEE advanced examination, correct?